So on all these problems we're trying to solve, got a few different types of equations here, just like we've been doing to review. This one here, we only have a in one place. So when I circle a variable, I see there's only one to circle. So I just need to get rid of everything that's over there with the a. So there's three things I need to get rid of. I need to get rid of this 3, this -1, and this 2. So which of those three things should I get rid of first, Clayton?
You're going to want to get rid of the 2.
Okay, and how do we get rid of that?
Since division, you're going to do multiplication.
Good. So over 2 means division. So we get rid of division using multiplication. We'll multiply both sides by 2. And when the 2's cancel on the left, what does that leave? 3a minus 1. And then on the right side, 7 times 2 is? 14. Okay. Then after we get rid of that 2, the next thing we're going to get rid of is the 1. And how are we going to do that? We're going to add 1. So we add 1 on each side. And on the left side, the -1 and the +1 cancel each other out, leaving what? 3a. And on the right side, 14 plus 1 is? 15. All right, then what? Divide by 3. And when those 3's cancel, we get a equals 5. And that is your final answer. How can we check to see if that's the right answer? Exactly. We could put 5 in anywhere we see an a, which would just be right there, right? So we go back to the original equation, put 5 in where the a is, and simplify this. And when we simplify the left side with the 5 there, we should get what?
15. 3 times 5 is
7. We have 7 on the right side, so when we simplify this expression with the 5 in there for a, we would get 7 over there also. Which does end up happening, because 3 times 5 is 15, minus 1 is 14, and then divided by 2 is 7. All right, so we can plug it back in to check our answers. In this one here, we still only have b in one place, so we're not going to have to worry about combining terms or anything. But this equation is special because it has a square in it. And what do I need to do to set this up besides circling the variable and drawing the line? I'm going to box the square. I'm going to box the square, which means that I'm going to box the actual exponent itself and everything that's in the parentheses, because that's what's being squared. All right, now, to get rid of a square, I have to have the square by itself first. What's the first thing we need to get rid of to get the square by itself? Okay, and how are we going to do that?
Subtract 2.
All right. Subtract 2 from each side. The 2's cancel on the left, leaving everything else, right?
Yes.
So we've got the 3 times 3b plus 2 squared. And on the right side, 77 minus 2?
75.
Okay, then what?
You need divide 3.
Good. So when we put a box around the square, we see we need to get rid of the plus 2 because it's outside the box, but the 3 is also outside the box. So we get rid of that times 3 by dividing by 3. So we divide by 3 on each side, and those 3's cancel, leaving
25.
on the left side.
3b plus 2 with the square roots.
Not the square root, a square.
Yes.
And 75 divided by 3 is?
25.
Okay, now what?
Now you have to do the square root.
Okay, yeah, so the square is by itself now, so we can get rid of the square, and we get rid of the square by taking the square root.
On both sides.
So we take the square root on the left, we take the square root on the right, and the left side, the square and the square root cancel, leaving
3b plus 2.
3b plus 2. On the right side, we're looking for the number that multiplies by itself to get 25, which is 5.
So you got to do another problem on the other side.
Okay, good. So since 5 times 5 is 25, that works, but -5 times -5 is also 25, so we need another equation. You guys should have room over to the right. I don't have room over there, so I'm going to put mine on the left, but you get the idea, right? It's the same thing. So I've got -5 on the right side of the equation. What's going to be on the left side of that equation?
Same thing.
Yeah, we're still going to have the 3b plus 2 over there. All right, so when we take the square root of 25 could be 5, but if you're solving an equation, it could also be -5 because -5 squared is also positive 25. All right, so now we need to keep solving, Alvin. What do we do next?
Subtract 2 from both of them.
Okay, subtract 2 on each side. When those 2's cancel, we get 3b equals 3, and then
Then you divide by 9. Gotcha. Equal 9.
What's 3 divided by 3, Alvin?
9.
So we get b equals 1 on the right side for one solution. And then we're going to come over here to this equation and solve this one. And Blake, can you help me with this one? We're going to solve this equation. So what do we need to do to get b by itself there?
Subtract 2.
Blake's going to help me with this part. So we subtract 2 on each side. When those 2's cancel, we get 3b equals what? -7. And then
You can't divide by 3. So
why can't you divide by 3? We need to get the b by itself, right? How else are we going to get the b by itself?
divide by 3.
Okay, we're going to divide by 3 on both sides. And so when the b's cancel, I'm sorry, the 3's cancel over here, we get b equals, now on the right side, -7 divided by 3 gives us a decimal, right? But rather than write it as a decimal, we're going to write it as a fraction. So we're just going to leave it as -7 over 3. Can we reduce that fraction?
No.
No. There's nothing that goes into 7 that also goes into 3, so that is your final answer. So we do get 2 answers here, and both of them work. If we plug both of those in for b up here, they would both give us a true equation. So we need to give both of those as our answers. We will start, just like we always do, by circling the variables. So we circle the c, and this time we have c in a bunch of different places, meaning that we're going to have to do some simplifying. And the first step to simplifying that is going to be what, Joel? So we're going to use a distributive property. We can't combine like terms right now because if we look at the like terms on the right side, we have like a 2c and we have a c, but both of those are being multiplied by something that's outside of the parentheses. So this isn't really a 2c, it's actually a 6c. This isn't actually a c, it's a -2c. But we don't know that until we distribute. So we're going to distribute first. So George, what do we get when we distribute here the 2 times c? Okay, and then...
-10.
Good. So it's 2 times -5 gives us a -10, and we'll bring down that -1. On the other side, George, when we distribute this -2 here, what are we going to get?
-8.
Okay, good. Remember, a negative here times a positive gives us a -8. All right. Then we also have this 3 over here to distribute. 3 times 2c is?
6c.
Okay, and that's positive, right?
Yes.
So we'll put a plus 6c, and then 3 times -5?
-15.
-15. And then we do have one other thing that we didn't bring down yet, which is
2.
the 2 all the way at the beginning of the right side here. All right, so now that we've distributed, we don't have any terms that are being multiplied by anything else, so what can we do now, Joel? So on the left side, Joel, what can we combine? All right, so we're going to combine like terms. On the left side, Antoine, what like terms do we have?
2c.
The 2c, what do we combine that 2c with? Can we combine the 2c with anything? No, because it's the only c over there, right? So since we can't combine that with anything, what are we going to do with that?
It's too long.
We're just going to bring that down. All right, so then, Antoine, you said the -10 and the -1 are like terms? When we combine a negative and a negative, those are going to combine to give us a bigger negative. So what are we going to get there? -11, good. So -10 minus 1 gives us a -11. Then over on the other side, we do have some c's that'll combine. The -2c and the +6c give us what? Antoine? -2c and 6c combine to give us, what's 6 minus 2? Okay, we have 4c. Since the 6 is positive and the 2 is negative, we're going to have some canceling, but we do have more positives than negatives, so we get a positive 4c there. And then we also have the 2, the -8, and the -15. Let's do this. Let's combine it this way. How many negatives do we have total between the 8 and the 15? How many negatives total do we have? We have 8 negatives here and 15 negatives here, give us a total of 23 negatives, and then 2 of those are going to cancel with these 2 positives, so we end up with 21 negatives. So when we combine all of those, we get a -21. After we combine like terms, we still have variables on both sides. We can't get the C by itself as long as the C is on both sides of the equal sign. So what do I need to do to get C on one side of the equal sign? Kaylin? Okay, why the 2C? Why not the 4C? Yeah, we want to get rid of the smaller one. And it wouldn't be wrong to get rid of the 4C. We would still get the right answer as long as we do all our work correctly. But
Take another step.
it would maybe take another step, and we would have to work with a negative number where we shouldn't have to. So to work with positive numbers, we're going to get rid of the smaller one. So we've got negative 11 over here, and then on the right side we've got 2C minus 21. What next? We have C in one place now, so what can we do, Kaylin? We can get rid of stuff. We get rid of the minus 21 by adding 21. When those 21s on the right side cancel, that just leaves the 2C. And then on the left side, we have a negative 11, positive 21, give us 10. Positive or negative? Positive, because there's more positives than negatives there, right? And then what?
Divide by 2.
Divide by 2 on each side. And the 2's cancel, leaving C all by itself. And 10 divided by 2 is 5.